Alright, so we'll be talking about Python data structures and what the complex Python data structures are, and then going over the key concepts of them. That'll be the discussion, but first, let's start off with the definition of data structures. Data structures help us organize and store data so they can be accessed and worked with efficiently. With these data structures, they help us manage and utilize organized data for our upcoming analyses. So, and I wanted to provide a few examples. So there are cases like this, creating visualizations. And then this is from Python versus R of Stack Overflow, which in some case Python was a better language for users in Stack Overflow. And then this analysis or dataset was provided by Anokas on Kaggle, which website you'll learn later. And then within organizing data and building these data structures, you can also work with other software visualization tools or just any other software. So here's a Tableau visualization of some data, coffee data set for countries, and this is the top 10 coffee producing nations. So we're working with items like that in the future. Okay, and then today we'll be talking about 4 critical and complex non-privileged data structures used in our analyses within Python. But before diving into these non-primitive or complex data structures, I just want to talk about simple cases or primitive cases. And primitive data structures are just simply like one valued things, so like the value 1 or like value 2, things like that. Nothing of the sort, just like one little unit. That's how I would call a primitive data structure. And then a non-primitive data structure is just having these units all in some big container, so that'd be within a non-primitive data structure. And so here are a few examples of the primitive data structures within Python. These are 4 popular ones we will be utilizing first. I'll be utilizing 2 of them for this overview, and then there'll be more later on. So the first one's string, second is integer, third is float, and then fourth is boolean. Okay, and then now we will be using string and integer for the non-primitive data structures that we'll be working with in Python. And then these are the following: lists, sets, tuples, and then dictionaries. And then as we continue on the course, we'll solidify our understanding of these data structures to go into even more things like data frames and JSON, which sounds kind of cool, and then data structures within another, and then so forth. It'll be fun, definitely. Right, so we'll start off with just defining what strings and integers are for this primitive case. Sounds kind of cool when I say primitive. Anyways, we define strings as a combination of string characters. They could be 0, 1, or more characters within a string. And then the following examples of strings are here below. So the first variable equal to parentheses with a blank. So blank or nothing with these parentheses are commas as well. That's considered a string. 1 letter is considered a string for the second variable, string var2. And then the third one is a sentence string. So these are all strings right here. And if I print out these strings, or excuse me, if I display these strings, we'll learn about what the print function does, and that's what it does. It displays strings. You'll see that we get a blank here, 1 letter, and then the full sentence. And just notice that there are no parentheses with these inner parts, and that's just because that is how we declare and categorize these data type string data types to the variable, but when you're actually displaying them non-raw, when you print them out, they just come out as the inner parts, or the string, the text that comes out to be. And then let's just confirm that these are actually strings. So we're going to display what the string types are. So string number 1 data type, what's that? We're going to use this function called type to determine that for each of the variables we did above here. So I'm going to display the string 1, 2, and 3. What are their types? And then we see right here that they're all strings. Cool. Any questions? Okay. Now we go on to integers. Integers are just considered whole numbers. So their values like 1, -2, or 1738. And then whole numbers are certainly not like decimal values like 3.14 or maybe $1.99. These are considered float data types instead, and we'll talk about those later on. The following examples of storing an integer data type and what is the data type that variable stored in, as we saw in the case of strings. So here are our 3 int variables. So the first variable, integer variable, is 1. The second one is 213. There's no parentheses, notice that, and also notice the color coding, where which is cool in Python, which is establishes that these will be values rather than integer values rather than string values. And then a float. Oops. Assume this is an integer, 3.14, so I'll assume that, my bad. Anyways, so as we display these values, we do in fact see that we get the value 1, 213, and 3.14. So now let's see these let's see and determine that if these 3 variables are in fact integers. So we're going to print what are these 3 integers. Is this third one actually integer, which I accidentally said earlier and shouldn't have said, but because I spoiled it. Anyways, so as we go through that, we see for every type of the variable, each respective variable, we have an integer, and like I spoiled, we have a float. So again, integers, not decimal. So now that we know what strings and integers are, now we can proceed on with the non-primitive cases, or these storages of primitive values. Basically, we're going into the non-primitive data structure case. So the first one I want to talk about is a list. Lists are popular storage systems or containers that can be modified, sequenced, and sorted, and then so much more. And then there's documentation with that in the Python website, which I should display it up in a tab, but we'll do that later. So let's just show what a list actually is. So a list can, it can be empty. And then also lists can contain these primitive values. So earlier we had A, and then like letters would be like B, and then blah. So lists have the ability to have these primitive values, multiple primitive values into this container, and then in this container you'll see that in fact we have all these strings as we saw earlier. And then similarly, we can have a list of integers. And then you can also have a list of any other variable type as well. So we see right here is 1, 2, 3, 4. So we have all integers. But what's also cool is we can have a mixed bag of values. So look how for this list 4, I put both an integer and a string in there, and that's kind of perplexing in a way, because in other coding languages we kind of don't see that within lists. I believe. I'm trying to remember my Java days. Anyways, printing out this list 4, we do see in fact we have the value 1 and then the string in quotes or in like commas and little letter A. So that's cool. And then what's also cool is if you notice they're kind of sorted by the values. So let me say if I can put a C before this. Let's see if that works. Okay, no, but I can sort it by doing a function. Let's see if we can do this. Sorry. Okay, my bad. Let's see. I'll do it later. Okay, but anyways, there's a function, and you can sort these values. Okay, anyways, let's proceed on. So again, string lists have containers that contain one variable type or several variable types. And what's also cool is about lists is you can modify the list, as I previously mentioned. And sets are just like lists, except you can store store these containers uniquely. And what do I mean by that? So let's go with like set 1 equals 1, 1, 1, 1, 1, and then like 2, and like A and B. So there's uniqueness to this set. Sorry. Print. Okay, cool. So for the set in curly brackets, you can notice compared to list where it was in brackets, the set has a unique set of values. I had several ones, but only one came out weird, and then 2 A and B. So that's excellent. And then it's unorganized as well. And then sets can also be faster processed compared to lists. So like processing in terms of computing speed. That's what I mean by that. And then there'll be more of that later. And then this is next we're going into tuples. So tuples are an interesting type of container. They are utilized when you want to just store values concretely, and so that they cannot be changed or altered. This is immutable, so tuples can't be tuple, if you get the idea. And then they also have faster access than lists, and like similar to sets, and then they can be sequenced as well. And for tuples, you just have that right there. So instead of curly brackets or brackets, they're in parentheses. Yeah, so let me do that, and then we do a second tuple equals, and then these can have duplicates, of course. So 2, and then say it there. This is a set, and then if I were to modify that with a function or something else. Let me see. Maybe this will override it. I'm not sure, but essentially you can't. When you try to modify the actual tuple, you can't alter it. But let me see if you can override it. I'm actually curious. Okay, you can override it. Okay, but if you utilize some function or some type of function or transformation on a tuple, it's not possible. You could concatenate tuples. Certainly could create some new tuple out of it, but edifying the underlying one cannot do. Alright, and then briefly let's talk about dictionaries. Dictionaries are just dictionaries are utilized for having some values categorized by certain sections. That is, you want to access like maybe a primitive or not a non-primitive value or a container by some key. And then let me explain that. So dictionary 1 equals, and then I have the curly brackets just like a set, but then I'll have a key 1 be a list. And then if I print that dictionary with that key, what do you think I'll get? We'll find out. We get the values 1, 2, 3 because we went into the dictionary, looked through the chapters, found the right chapter or the key or door, I guess you can say, whatever, with an analogy. Used the key 1, opened the door, and then there we got the array. Yeah. And then that's just a quick overview of data structures. Thank you.